Two Spark pipelines, same cluster, same data source. Pipeline A finishes in 6 minutes, pipeline B finishes in 55 minutes. And the difference is one extra line of code. Hello everyone, welcome to Big Data Factory. Today I'm going to show you why that happens using one simple idea, wide versus narrow transformations. By the end of this video, you will be able to look at any Spark code and predict this will stay in one stage and run fast, or this will trigger a shuffle and become expensive. No heavy theory, just a technical story with clear rules you can reuse. Let's start with the story. A teammate messages you, "Bro, yesterday the job finished in minutes. Today it's taking forever." You open the code and everything looks normal until you see one new requirement. We need revenue per customer. And they added groupBy of customer ID dot sum of amount. That's it, one line. But that one line can change the whole execution model. So the investigation starts. What changed inside Spark when we added that line? Before we define wide and narrow, we need three Spark basics. Only three. 1. Partitions. Spark splits your dataset into partitions. Each partition is a chunk of data. And number 2, tasks. One partition is processed by one task. And number 3, stages. A Spark job is broken into stages. Inside a stage, Spark can run many tasks in parallel. Now here is the key. Spark creates a new stage when it needs a shuffle. So you can remember this simple mapping: no shuffle, same stage, shuffle, stage boundary. And wide versus narrow is basically about one question: does this operation require a shuffle or not? Now let's define it cleanly. A narrow transformation means each output partition depends on only one input partition. In simple words, data can be processed locally without moving across the network. Examples in Spark including things like filter, select, with column, map, flat map. They feel cheap because Spark can pipeline them. Wide transformation. A wide transformation means an output partition depends on multiple input partitions. In simple words, Spark must move data between executors, so related rows end up together. That moment is the shuffle. Typical wide transformations: group by or aggregation, distinct or drop duplicates, join, order by, and repartition. So your mental model can be one line: narrow is equal to local work, wide is equal to shuffle. Let's make it visual in our head. Imagine each partition is like a lane of traffic on a highway. Narrow transformations are like, do some processing within your lane. Wide transformations are like, everyone must reorganize by destination city. That means cars from every lane must cross lanes and regroup. That regrouping is the shuffle. And shuffle is expensive because it involves serialization, network transfer, sorting and merging, sometimes spilling to disk. So wide transformations are not bad. They are just the ones you have to treat carefully. Now I will show you narrow transformations in a way that feels real. Suppose we have a clickstream or orders data. A typical narrow pipeline looks like filter only one country, select only needed columns, compute a derived column. What we are looking on the screen is a PySpark style of code. This is mostly narrow. Why? Because each row can be processed independently in the same partition. No need to move rows to other executors. Spark can fuse these operations and run them inside one stage as a pipeline. So if your job is mostly narrow transformations, it tends to scale nicely. Now comes the line that often turns everything wide: groupBy. Why is groupBy wide? Because Spark must guarantee that all rows for the same customer ID meet each other. If customer 42 has rows in 50 different partitions, Spark must move these rows so they land in the same partition for aggregation. That regrouping is the shuffle. So groupBy is a classic wide transformation. Same for distinct. If you say remove duplicates, Spark must compare rows across partitions and shuffle again. Same for most joins. If both sides are big, Spark usually shuffles data by the join key so matching keys meet. So wide transformation are the ones that answer questions like, give me totals per key, give me unique rows, give me global order, combine these datasets by key. Those questions require coordination across the cluster. Now let's go back to the story. Before the new requirement, the pipeline was filter select with column, mostly narrow transformations. After the new requirement, the pipeline became filter select with column groupBy. That adds a shuffle. That adds at least one stage boundary that can add disk bill, network cost, and long tail tasks. So one line can absolutely change runtime. And now here is the practical part. How do we prove it? Not guess it. There are two beginner friendly ways. Method 1, keyword detection. If you see these operations, assume void until proven otherwise. Group by, aggregate, join, distinct, drop duplicates, order by, sort, and repartition. And if you see these, assume narrow. Filter, select with column, drop, map, or flip map. This rule is not perfect, but it's good enough for 80% of cases. And we have second method, that is explain plan for exchange. In Spark physical plan, a shuffle often shows up as an exchange operator. So a simple habit is run df.explain of formatted, look for exchange. Exchange usually means shuffle, white transformation, and then stage boundary. So instead of arguing, you can prove it. Let's do a short example narrative. You run a Python script and you see exchange. That exchange is your smoking gun. It means Spark is reshuffling data by customer ID. Now you understand why the job suddenly got more expensive. Now, one more thing, stages and the shuffle wall. Spark tries to execute transformations as a DAG, but it can only pipeline across transformations when dependencies are narrow. When a white transformation appears, Spark hits a wall. It must finish one phase, write shuffle data, then start the next phase. That's why white transformations create separate stages. So the stage story is, in the stage 1 it will read plus narrow pipeline. In the stage 2, it will shuffle plus aggregation or shuffle plus join. In the stage 3, maybe another shuffle if you do something else wide. So in Spark UI, when you see many stages, it often means many shuffle boundaries. And this is why wide versus narrow is not just theory, it's literally how Spark breaks your job apart. Now let's make it even more practical. Wide transformations are not bad, but they are where most performance problems live. So the real question becomes, when I must do a wide transformation, how do I make it cheaper? Here are technical rules explained in normal words. Rule number 1, reduce data before the shuffle. If you do group by or join, try to make the dataset smaller before you hit that wide operation. That means filter early, select only required columns. And rule number 2, avoid unnecessary global operations. Operations like order by or wide, because global sorting requires full data movement. If you only need top 10, use patterns like limit after appropriate ordering or use approximate strategies depending on requirement. But the principle is global sort is expensive. Similarly, distinct can be wide and heavy. If your goal is to remove duplicates by a key, drop duplicates of key still triggers shuffle, but at least you control the columns and the meaning. So be intentional. Ask, do I really need global order, or do I really need distinct across the whole data set? Rule number 3, partition control matters. Repartition versus coalesce. This is a common beginner confusion, so I will explain clearly. Repartition. This is usually wide. It triggers a shuffle to evenly redistribute data into n partitions. Use it when you need better parallelism and are okay paying shuffle cost. Coalesce. This is often narrow when reducing partitions because Spark can collapse partitions without a full shuffle. Use it when you want fewer output files or fewer tasks and you want to avoid shuffle. So repartition is equal to shuffle and it's wide, and coalesce is equal to usually no shuffle, narrowish. This one difference is huge in real pipelines. And rule number 4, joins are often wide but can be optimized. A standard join between two big datasets is wide because Spark needs to shuffle by join key. But if one side is truly small, Spark can use a broadcast join strategy and avoid shuffling the big set. You don't need to master broadcast join today. Just remember, most joins are wide unless Spark can broadcast a small set. So wide versus narrow is a foundation for understanding join strategies later. Now let's return to the original story and solve it. The job slowed down after adding groupBy of customer ID. So we apply the rules: reduce rows early, like filter early, reduce width, select only needed columns, check partitioning, make sure we are not creating too many partitions unnecessarily, and then the last one, confirm shuffle boundaries using explain and Spark UI. Then we rerun and compare runtime. What you just did is not tuning magic, it's simply understanding whether the pipeline is narrow or wide and shaping the shuffle cost. Now, quick recap using a simple cheat sheet. Narrow transformations, usually no shuffle. Examples: filter, select, with column, map or flat map, drop. Wide transformations, usually shuffle. Examples: group by or aggregate, join, distinct or dot duplicates, order by or sort, and repartition. One line rule: if this operation requires bringing some keys together or a global ordering, it's a wide. Let's do a 20-second quiz to lock it in. Question 1. Filter of country is equal to IN, whether it's narrow or wide. That's a narrow. Question 2. Group by of customer ID, whether it's narrow or wide. A wide. And question 3. Repartition of 200. It's a narrow or wide. It's a wide. Coalesce of 450. It's a narrow or wide. Usually narrowish. Often no shuffle. If you can answer these questions, you already understand the core. To close, remember what wide versus narrow transformations really give you. They let you predict Spark performance before you run the job. They explain stage boundaries. They explain why some lines of code explode runtime. So this is all for today, and if this video helped you understand Spark execution clearly, please do like, share and subscribe to my YouTube channel, and do let me know in the comment section what you feel about this video. We'll meet in the next video. Till then, bye bye.